So this has actually been a really good order of presentations, because everything you're going to see here is a manager script. And they were all started life as being copied from another manager script. I think even the so-called expert APSIM users very rarely create a manager script from complete scratch. The other thing I'd add on to Justin's thing is that if you find if you're uncomfortable with C# and you find a manager script in C# that looks like it probably does the job, but you'd really like to see it in VB, there's some really good online tools for converting C# to VB. It won't get you 100% the way there. There'll be some question marks there, but it'll get you so close that it's good enough. And if you just Google convert C# to VB, or the other way around, it will get you there. Really handy. So this session is about multi-paddock simulations. And the first thing I have to say about multi-paddock simulations is, first of all, consider if you absolutely have to do a multi-paddock simulation. They're complex, they're slow. The only reason for doing a multi-paddock simulation is if something in one paddock is affecting the other in real time. So that's, for example, a resource can only be in one place or another. So I'm going to use a couple of examples here around irrigation. So imagine you've got some irrigation gear and it can only be in one paddock or another paddock. So if you were trying to construct some irrigation rules, then it might be useful to have multiple paddocks in the simulation. Of course, another example is when you're trying to simulate livestock in a farm. Again, they can't be everywhere all at once, or at least a single animal can't. So there's some interactions between paddocks. Another example is where you're actually trying to simulate different areas of the same conceptual paddock that have different characteristics, different soil types, different slope, or something else like that. So that maybe if it's sloped, maybe water is running off one part of the paddock and into the other. Now, with those type of examples, you can't run independent simulations and then muck around with the results after the fact and get the right picture. So you need to have multiple paddocks in the simulation. And those are really the only cases when it's worthwhile really doing a multiple paddock simulation. So, having said that, my first example is something that could have been done as a single paddock. The reason I've done this as the first example, though, is to keep it really simple, to try and show you some of the principles. And then the next example I'll show you as an example where it couldn't have been done as a single paddock simulation. So this first example is what if we're got this hypothetical farm that has, in this case, 7 paddocks. This is a farm that's growing irrigated forage for producing hay or silage or something else like that. We've got one physical irrigator that can rotate around the paddocks, but we have unlimited water. And what we want to do is simulate the movement of the irrigator around the paddocks. Now, you'll see this is a thing I'm not supposed to bump. You'll see from the simulation that what I've got is up at the top level of the simulation, I've got 2 manager scripts. And these control the things that happen at the whole farm level. Each of the paddocks are, as you can see, these paddocks are linked to the first one. They're all exactly the same. They're complete replicas of each other. And I also have a manager script within the paddocks, which in this case is applying lots and lots of fertiliser because we're removing lots and lots of dry matter. Now, here are what the farm level manager scripts look like. They're no different really from the ones that Justin's just shown you. You've got, in this case, a properties tab, which gives us some stuff to do with how we're going to manage the irrigation. You can choose the initial location of your irrigator, and you need to choose one of these paddocks. the number of days for that the irrigator needs to be in each paddock in order to irrigate the whole paddock, how much irrigation can be applied each day, and what time of the year the irrigation can happen during. And then the script starts looking like something like this, and this is in C#, and I'm pretty sure that around about this point, some of the real experts in C# are really starting to start cringing. Like I said earlier, I speak C# with a Fortran accent, and I still write quite a lot of my C# by using online converters. But the result is I keep it pretty simple so that I can follow it. Now, so following from Justin's examples earlier, these here are the parameters that came from that parameter tab. The only input into this script is the figuring out what day it is. And the rest of these variables that are declared here are things that are outputs from the model. And we need to know things like the current location of the irrigator and something to help identify the paddock. Now, one of the things that you pretty much have to do every time you've got a multi-paddock simulation is you need to know how many paddocks you're dealing with. And this is the way I go about it. How easy is it to see the code here? Difficult? Is there a way of blowing this up a bit? Increasing the font?
Unfortunately.
Right.
Not through APSIM. You can paste it into Notepad or something, but not through APSIM.
Is Notepad on this computer? I do have this. Is Notepad on this computer?
I can put it into Word or something like that. You can see that.
You can? Okay, right. So, to find out the number of paddocks in the simulation, you cycle through the things that are declared as paddocks, and it looks for child paddocks. So this manager is up at the top level of the simulation, and what it's looking for is paddocks that are underneath that. So it's cycling through each one of those paddocks, and it's just counting 1, 2, 3, 4 each time it comes through it. And that cycles through the paddocks and does a count of them. That's all that we really need to know at the start of the simulation. When it comes to each day, which is what the prepare phase is in the manager scripts, first of all, you need to figure out whether you're within the irrigation season, because if there's no water supply or it's not legal to irrigate, then you can't. Then you need to figure out if there's how long the irrigator's been in the paddock. So you increment the number of days that it's been in the paddock, and if it's more than the 7 days that you had on the parameter script, then you set the move irrigator to being true. As a separate loop here, because eventually these rules need to be a whole bunch more complex than this. For example, you shouldn't be irrigating when you're trying to make hay or silage. If it's true that the irrigator gets moved, then you increment the paddock number, and if it's greater than the number of paddocks, you loop back down to 1, and you construct the name of the paddock that the irrigator is going to be in. And then the real bit of the work happens, which is for each of the paddocks, which is again for each of these paddocks, if the paddock's full name equals the current location of the irrigator, then increment the number of days in the paddock, and then these 4 lines of code are things that just apply the water to the paddock, and you just steal those from another irrigation script. And the harvesting script looks pretty much the same, except that it's cycling through the paddocks and removing some of the dry matter when it's time to do that. This simulation's been pre-run so that I can make sure that it ran, but also it saves a little bit of time. As I said, as soon as you start adding paddocks to the simulation, it adds to the simulation time, and it takes a 7 paddock single simulation will take longer than 7 single simulations. So this is why you only do it when you need to. And what we can see here is that we've got some farm dry matter that's going up and down, and we also have some plotting, plot of what's happening on cumulative dry matter from the paddocks. When you're dealing with multi-paddock simulations, it's important to understand the scope of the data that comes out of it. Things that are in output files underneath your paddocks are only available to graphing components, things like that, that are also within the paddocks. If you've got, I mangled that. The output component, any output component within a paddock can only see its own outputs. It can't see the outputs from another paddock. If you need to get something that aggregates across several paddocks, then you need to have an output component that is essentially on the same level as your paddocks, so that it can pick up the results of manager components that are up at the same level, or somehow aggregate the paddocks. And that's the only way to get whole farm outputs. So we have that simulation, and here is a result of the irrigation applied to the different paddocks. You can see the suite of paddocks, and just essentially the same irrigation but happening at different times. Like I said, this is a stupidly simple example, and this could have been done just as easily, in fact more easily, as a single paddock simulation, because all it is the irrigator disappearing for some interval before coming back to the individual paddock. There's nothing happening in one paddock that really influences the other. So let's move on to an example where it does matter. Am I going for time, Justin? So this is a more real example. It's some current research that's going on. I've simplified this down quite a lot so that can try and explain what's going on in this within the time available. The question here is, we know that soils are quite variable within paddocks, and if you've got a fixed irrigation system like a centre pivot system, then you've only got one irrigation rate that you can put on, and once you start irrigating a paddock, you really pretty much have to finish, unless you put some fancy technology on it. There's also some pretty good technology coming that's becoming into more standard usage, where you can automate the scheduling of your irrigation based on soil water deficit measurements or soil water content measurements. And this can be automated, it can be hooked up to your irrigator, and it can control it. But if you've got a variable soil in your paddock, where do you put your irrigation sensors? So this example is, let's say we have a paddock that's got a range, very simply here, just 3 different soil types, with 40, 70 or 120 millimetres of available water. And this very simple example, they're just at this, they're 1/3 of each soil type. Now, this is a true multi-paddock simulation because only one of the measurements from only one of those paddocks is going to affect the irrigation of all of them. And the timing of the irrigation evolves during the simulation, so it really does need to be constructed as a multi-paddock simulation. The irrigator manager it's very similar to the previous one. It's got a few different parameters, and the top one here, instead of where does the irrigator start, is what paddock is the sensor located in, or what soil type is the sensor located in. And pretty much everything it's not that much different to what you saw earlier. And what happens with this one is during the start of the day, that's the on prepare phase, it loops through the paddocks and checks to see which, if the current paddock is the one that's got the sensor in it, and if so, it assesses to see what the soil water deficit is, And if the soil water deficit meets the criteria and it's the irrigation season, then it's through another loop. It loops through all of the paddocks and applies the same amount of irrigation to all of the paddocks, which in this case are actually just soil types within the same physical paddock. This whole paddock manager script just does some harvesting and things like this. This is growing grass, so if we don't harvest it, it's not going to keep on growing. Within the paddocks, which as you can see, they're all pretty much linked, we have a couple of things. We're going to add some fertiliser to keep the grass growing. Just for some convenience of reporting, I've got a nothing manager script, which simply just makes a label available for printing out. There may well be a better way of doing this, but this is what I knew how to do. And the soil types in each of the paddocks are differing, and really the only difference between them is the available water. And I think I have pre-run this simulation as well. Oops, I thought I had a manager component there. No, it's all here. So what we have here is, this is a reporting component that is underneath this particular simulation, where the sensor is in the lightest of the soil types and the one with the least amount of available water. All of these plots show the lightest soil type in blue and the deepest soil type in green. And these are the stress factors that apply to the pasture growth, temperature, nitrogen, not too much nitrogen stress, and water stress. And what you can see here is in ag pasture, 1 is no stress. So you can see that there's stress appearing earlier despite the irrigation in the lighter soil, and it's later and later in the season before the deeper soil sees some more stress. And you can see that that's having some results in the pasture growth rate. That results in different amounts of cumulative growth from those different soil types, different amounts of drainage, and so on. And when it comes to sorry, that wasn't what I wanted there. That one. So when it comes to the whole paddock growth, then it's an aggregate of the 3 different soil types, and that was achieved by having a manager component at the top level of the simulation. The next couple of simulations are exactly the same, except that the irrigation sensor is in either the medium or the deepest soils, and hopefully yes, this gets a little bit complicated. So this is the growth rate from the accumulative growth rate from the shallowest soils when the sensor is in the shallowest soil, in the medium soil, or in the deepest soil. And this is the deepest soil with the sensor in the shallow, medium, and deep soils. And in all cases, you can see that there's more growth when you put the sensor in the medium soil type, in this case. You might think that the shallowest soil would be the sensiblest place to put the sensor. However, this is a deficit irrigator, and it's got quite it can irrigate quite a lot. It needs to get down to 25 millimetres deficit, and when it does that, it'll put on 15 millimetres of water, provided there's at least 4 days between irrigations. That's actually pretty frequent, but with a particularly shallow soil, it can take the stress hits early, the water use rate, the water use of the pasture slows down, and it takes longer to get down to that deficit than it does in the heavier soil. So it's kind of once you work through the logic, it makes sense, but it's not immediately. You might think put the sensor in the shallow soil, you get the most growth. You'll also get the most water usage. You might also think you might get the most water usage out of it, but this is the different irrigation usages across those different scenarios. This is when the sensor's in the lightest soil, and it's just taking longer between irrigations to accumulate the right amount of deficit. What you can do, of course, is change the irrigation settings. And in these simulations, I haven't changed the irrigation. Hang on. Damn it. And are these linked? Can I do it quickly? No, I can't. So what I can tell you is what I did, I thought I had run a series of simulations before this started, and I don't want to be doing that now by the looks of it.
You can if you want.
I can?
Yeah.
I'll stuff it up. I needed to have those parameter changed before I did it. I've got to do it in a couple of different places. It actually doesn't, the settings that you would need in order to get the sensing of deficit, the shallow soil being the best sensor of the irrigation deficit for the whole paddock, essentially require irrigation almost every second day with very small amounts of water, and in which case your other irrigation losses due to pumping, evaporative losses, uniformity losses will just kill the whole water use efficiency picture. So in these particular simulations with this range of soil types, the best location for the sensor was actually in the deepest soil, but it does depend on the irrigator characteristics. What I hope this example shows is that this is a genuine need for a multi-paddock simulation. Something happens in one paddock which affects the management in another paddock. And if you don't have something like that, or something moving from one paddock to the next, then there's really no need for a multi-paddock simulation. And just trust me, or give it a go, you'll find out pretty quickly. As soon as you move into multi-paddock simulations, you get an awful lot of power, but it's also, they're very hard to set up. You end up generating an awful lot of data, and they go wrong really, really easily. And I don't know if Jeremy's done much debugging of these type of simulations, but they get very hard to debug. Thank you.